So the next part of our linear functions unit is point-slope form. We've already learned slope-intercept form. We've already learned how to find the slope. So we're going to find a different form of linear function. It's still the same linear function that we've been working with. So if it was y equals mx plus b, there's an equation in point-slope form that is of the same exact line. So don't think of this as something completely new. It's just a different way of writing something we already know. So in point-slope form, we have different parts. M, we already know is our slope. Right? M was slope before, still slope now. So we have an x1 and a y1. Those have come from coordinates in the past. So these two parts of our equation come from the coordinate x1, y1. So that's just a point. Now I think you can figure out why this is called point-slope form when we use a point and a slope. How we use them I'll get to in a second. Y is just the dependent variable. And x is still the independent variable. So those don't change. Just like in y equals mx plus b, y and x stay in the problem no matter what. The only difference here is we are including slope and a point, not just a y-intercept, so a whole point. Okay, so this is the format that we're going to use for some of the upcoming problems. Say I gave you these formulas in the point-slope form. Y minus 1 equals 2/3 x minus 4. And I'm asking you for the point and slope. The slope is easy. It's whatever's before the parenthesis. It's before the x like it is in slope-intercept, so it's going to be 2/3 for this one. Now the point. If I had to guess, you'd be tempted to just call it -4, -1. But if you look back to our form, our regular formula, there's a minus here. So, and this is the backwards part of it. If this is minus and the numbers here is whatever number it might be, that number was positive originally. It's only different if there were a plus there. So let me show you an example. On this one, since it's a minus, we say this is a +4, and since this is a minus, we say it's a +1. So our point is 4, 1, because we go x1 or y1. It can be a little confusing at first, but once you get the hang of it, you'll figure it out that you basically do the opposite of what you see here. So let's try for this one, the next one. Problem 2. Y plus 3 equals 4 times x minus 2. The slope is 4. So we have x1 and we have y1. Well, x1, there's a minus in front, so we take the opposite and we leave a 2. 3, there's a plus in front. This means it was originally a negative, so we take the opposite and call it -3. So the point there would be 2, -3. Basically what you have to understand is whatever this number is, if the sign in front is negative, it's actually positive. If the sign in front is positive, it's actually negative. You're just really taking the opposite. How about this third one? Y minus 10 equals -3/2 times x plus 7. Slope should be the easiest part to pick out, -3/2. The point, so we have x1 here, y1 here. So x1 is a +7, meaning it was originally a -7. And it's a -10 here, it's originally a +10. So that's all you have to remember is that this one little weird thing about the equation is originally everything's minuses. To make it work, you have to use the opposite of the number you're given. So if it was given to us as -7, 10, we know it's x plus 7, y minus 10. Please be sure to ask any questions in class you have on this one if that was confusing at all to you. Just think about it as the opposite of this and this. Just the sign here, whatever the opposite is. How do we use it? So if I was given a point and a slope, I could easily use point-slope formula, right? When you're given a point and slope, it goes right along with point-slope. So I can call the point x1, y1. I have my m. All I do is plug in. Y minus, I always start with minus because that's what my formula tells me. This number is positive, so I keep it minus. Equals 4 times x minus 5. Now, if that were a -5, I would change this to a plus. So say my problem were this instead. M equals 4, my point is negative 5, 1. I would say y minus 1, because it's still positive, equals 4 times x. Now since this is negative, that negatives become minus minus, which is plus x plus 5. So because of the negative, it makes a minus minus, which turns to a plus. Right? Two negative signs in a row means addition, because it's negative subtraction. So what if I was given 2 points instead of a point and a slope? This would be really hard to use slope-intercept for, because we can't really figure out the y-intercept. We can figure out the slope, so let's just start there. So for whatever formula we need the slope to start, so let's just do that right away. That should be your instinct. As soon as you're given 2 points, always find the slope. So we have 12 over 4, which is 3, a slope of 3. Now the reason I would choose to do point slope on this one is because you have 2 points and now you have a slope. So you choose either one as x1, y1. It wouldn't matter if you chose this point or this point, either one works. I just like the one with smaller numbers. So I say y minus 4 equals 3 times x minus 2. Right? They're both positive, so they both get minus signs. So we're going to try graphing at a point slope form. In this problem, I've given you y minus 2 equals 3 times x plus 1. What we need to pick out is our slope, m is 3, and our point. So we have x1 as x plus 1, so that means it's a negative 1 because of the minus minus or the sign changing. And y1 is negative 2, so that was a positive 2 to start. So the first thing I'm going to do is plot my point. Negative 1, 2. Right? I have nothing else to work off of besides a point and a slope, and I can't use a slope without a point. Which is why when we did slope-intercept, I put my y-intercept on first and use my slope to either side. Now I just have a random point that I'll put on my graph, and then I'm going to use my slope. So the slope here is 3, which is 3 over 1, or negative 3 over negative 1. So that means I can either go up 3, right 1, or down 3, left 1. And from there, I can connect my line. So it's the same exact process as plotting a point and using your slope off of it. The only difference is you have to find your point out of your equation, instead of it being given to you as b. So one last skill. Write an equation in point-slope form. So I've given you a line, and let's say I give you this point, 3, 3. I tell you to use that in your point-slope equation. Well, you can do a lot of different things here. You can find your slope using the slope formula, but in this one I'll just do it the manual way on the graph. So we're going up 3, we're going right 2. So that's 3 over 2, right? You could also just do that by finding the points if you wanted to, that this is 5, 6. That's completely up to you how you want to find your slope. Regardless, I now have a slope and a point, and I'm prepared to make point-slope form. So I could say y minus 3, because that's y1, equals 3 halves x minus 3, which is x1. And I've created a point-slope form from a graph. And I could use this point if I wanted to as x1, y1. Like I said before, it doesn't matter what points you choose as long as they're all on the same line. So I could have said y minus 6 equals 3 halves x minus 5. Both of those stay minuses because the numbers are positive. So both of these would be right answers. Any point you can pick off of your line, any corner of the box that you can pick out is an acceptable point. Just use your slope and whatever point you choose on the graph. Sometimes I'll tell you which point I want you to use. Sometimes it'll be up to you. Where we're going with this. So past just using it for its form, we're going to use applications where you're going to be given a nice word problem. You'll pick 2 points from it. So sort of like the Hachi problem for the slope-intercept, you're going to create 2 points, and then you'll find the slope, and then use point slope form and go from there. One other use of it, if we go back to this problem, is we can figure out this equation in slope-intercept form. So say I went to here. Let's see which problem's better. This one. So y minus 2 equals 3 times x plus 1. I can move this in a slope-intercept form by solving for y. So solve for y to get into slope-intercept. That's y equals mx plus b. So if I'm going to solve this problem, and I want to get y alone, I'm going to take care of this side first and distribute. So I'll have y minus 2 equals 3x plus 3, right? And I can add 2 over, combine it with the other constant over there, and say y equals 3x plus 5. So you can use this in a variety of ways. You can use it to graph, you can pick it off of the graph, you can find a slope and make the formula, you can use the formula from point slope to solve into slope intercept. So remember how I told you in the beginning that it's still the same type of line, it's just a different way of writing it. So we have the slope intercept equation. If you look at it, the y-intercept is at 5. So it's very accurate. It is the same line.